Hey there, let's do some factoring. Factoring, it's a great tool for solving quadratics. So we're going to be doing three types of factoring in this video, and they are listed here. GCF, greatest common factor, trinomials, which you have been working with recently in quadratics, and a difference of squares. So you ready to go? Let's do it. GCF, greatest common factor. So here's an example. Let's factor this expression. Now, greatest common factor means what we're going to do is we have two terms here, and they're added together. But we're going to pull out or find the greatest common factor between each expression. So I like to say that is we're going to pull out what is common in multiplication, what is common between these two terms. So we're going to start with the number. What's the highest number that we can divide into those two numbers evenly? Or what are the highest factors of those? Well, we see that we could pull a 3 out of here and a 3 out of here because 12 divided by 3 evenly gives us 4. So I'm going to pull out a 3. I say pull out, I'm trying to remove the common factors from that expression, and they come on the outside of our parentheses, you'll see. So I pulled out a 3, and then I say, what's the highest x variable that I can pull out of there? Well, there's two x's here, x times x, and there's 1 here, so I'm going to pull out 1x, because that's the highest number of x's I can pull out that expression. And these are like doing puzzles. So when you say I pulled a 3x out from this term, what's left over? Well, 3x times what will give you 3x squared? How about an x? 3x times x is 3x squared. So we've got everything taken care of. We pulled out a 3x and we're left over. Now we'll go to the next term. Now from this 12, we already took out a 3, and if we were to multiply 3 times something to get 12, we know that that would be 4. And we pulled out the x here already, and really what you're going to see is that factoring, in this case, is almost, it is the opposite of distribution. So if we were to just already say, well, we've got that 4, we've already pulled out that 1x. And when we distribute, just to check ourselves, that would be 3x times x is 3x squared, and 3x times 4 is 12x. And we know that we factored that greatest common factor properly. Now, there'll be lots of kinds of problems, but every time I see a factoring problem, I say, is there something common I can pull out all the terms in that expression? Let's factor trinomials. These are the most important factoring problems that you'll ever know because they're pretty easy and tricky and fun, and the more you practice them, the easier they get. So I want to just show you my process for factoring a trinomial. Trinomial, 1, 2, 3 terms. X squared and x and a 12. Now, if I wanted to say, is there anything common that I can pull out of all 3 of those? And the quick answer is no. There's no x here, so I can't pull any x's. Like the highest number of x's, well, I can't pull any x's out. And there's a 1 in front of this x, but there's no other number that I can pull out of all 3 of those. So this is not a greatest common factor problem. But doesn't it look very similar to your quadratic functions? Ax squared plus bx plus c, only b is negative in this case, and that's going to be important. But really, this is a trinomial that we can use a special process to factor. So let's factor, and I'm going to start at this c term, and I'm going to look out here. That's my constant. It doesn't have an x. And I'm going to say, what are the factors of positive 12? What are the factors of a positive 12? what multiplies to get to 12? So the first one, the obvious one, is 12 and 1, right? That's a positive 12. But what about a negative 12 times a negative 1? That would work because a negative times a negative is a positive, right? How about, what's another one? 6 times 2. That works. And a negative 6 times a negative 2 also works. And it's important to make sure you get those negatives. And what about another one? 3 times 4. Those are all the factors, and then a negative 3 times a negative 4. Those are all the factors of positive 12. Now these are very important numbers because now what I'm going to do is I'm going to add the numbers. So step 1 was to find the factors of this last term. And now we're just going to add these terms together. What's 12 plus 1? 13. What's negative 12 minus 1? Negative 13. What's 6 plus 2? 8. Negative 6 minus 2. Negative 8. What am I looking at? Oh no, which one's matching the middle term? That's what's happening. 3 plus 4, 7. Negative 3 minus 4, negative 7. I did all of them just to show you what's the number once I add all of those terms that will get me the number that matches the middle term. Which one? Negative 8. Ding, 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 ding. So these are the factors I'm going to use, negative 6 and negative 2, because that will add to get me a negative 8. Now that's the process. You just have to learn the steps and you'll get fast really quickly. So look at this. What I'm going to do now is I'm going to set up, and you always set up these parentheses. I'm going to set up 2 sets of parentheses. And I'm going to put an X in the first one and an X in the first spot of the second one. And now I'm just going to take this minus 6 and drop it in right over there, and a minus 2 and drop it in right over there. And this is my trinomial in factored form. Now you remember FOIL? FOIL, you could check your answers. What's x times x? X squared. What's x times negative 2? Minus 2x. What's negative x times 6? Minus 6x. And what's a negative 6 times negative 2? Positive 12. So we're checking, we're just foiling, which I think you guys are pretty good at foiling. Minus 8x because we combine those 2 middle terms, which usually always works out to get us a B term, and plus 12. There's my check, the original problem, but this is my answer. That's the trinomial factor. And we're done. Here we are, the easiest of all the factoring problems in the entire world, difference of squares. Now, you just have to recognize them, and it's a quick step. The first is there anything common? Is it a greatest common factor problem? Nothing common that we can pull out of those 2 terms. Is it a trinomial? No, it only has 2 terms. But here's something very important. There's a difference there. It's a very important part. And 144, can we multiply something by itself to get 144? Can we get the square root of 144 and get a perfect square? What's the square root of 144? 12. So we know that the square root of 144 is 12. 12 times 12, we need a perfect square, and we need the difference. That's the difference of squares. So we can take this easy step, and it's just a pattern and a rule, and I'll show you why it works. When we put our x here and our x here, and we do a plus 12 and a minus 12. Now, for your quiz to see if you watched the video, I want you to check by foiling and then show me why, when you FOIL this expression, do you get x squared minus 144? This is the answer. I want you to FOIL that and check. Remember FOIL? F-O-I-L. I know you do, and I think you know what it stands for. And I might ask you that as well, just to see if you watched my factoring video. These are you try problems. Do these problems in your notebook and show me the problems when I come back the first day of class that I get to see you, and you'll get full credit for watching this video. You will all be familiar with factoring. Have fun doing that.